we have a question here and we have to find the gradient of the function y is equal to 2x. So anytime you have a function in this form, let us know the type of function. We see that y is equal to 2x is the same as y is equal to 2x plus 0. So this is a linear function. So we can compare this given function with y is equal to mx plus c. So we have equation 1 and we have another equation which is equation 2. So the equation 2 is the standard form of a linear function. So the moment you have the two equations, the only thing you are supposed to do in order to determine the gradient is to compare the coefficient of the x in equation 1 and the x in equation 2. So that's what you are supposed to do. So the coefficient of x in equation 2 is m, write it where, is m. And the coefficient of x in equation 2 is, sorry, equation 1 is 2. So we conclude that m is equal to 2, which is the same as the gradient of the given function. All right. Now we can equally apply the concept of differentiation. That is, we are going to differentiate from the first principle as we did in one of the previous videos. So let us learn how best we can find the gradient without using this particular approach. So I'll first put down the formula that we have under differentiation where we can differentiate from the first principle. So let me put down the formula first. We have it as dy dx must be equal to f of x plus h, where the h the small increment in x minus the original function, all divided by f. I've omitted something, so let me bring it here. So you need to take the limit of this. So the limit as h approaches 0. Right. Everything divided by the small change, not f. So this is the formula that we'll be using. So you should keep it in mind. So I wanted to use this formula to determine whether we are going to get the same gradient to be 2. All right, so we have f of x. Let us know the component. We know the f of x to be the original function. And the f of x plus h means after the output that you get when there has been a small increment in the x value. And the h is standing for the small increment that has occurred in the input, or that is the x value. So let us take our function here. Our function y is equal to 2x. So this implies that our f of x is equal to 2x. All right. So f of x is the same as the y. So y is a function of x. So it becomes f of x. Now let us find our f of x plus h. All right. So it means if you have f of x to be equal to 2x and you are asked to find f of x plus h, it means wherever you see x in the function, you have to replace it with x plus h. That's what you are supposed to do. You are going to get it as the function is 2. So you are going to get at 2, then open bracket nicely. So here will be x plus h. So this is what you are supposed to get here. All right. So our f of x plus h becomes 2 multiplying x plus h in bracket. So we are going to get 2x plus 2h. All right. So we can now substitute this component into the formula. So we now have our dy dx being equal to the limiting value of our f of x becomes our 2x plus 2h, and our original function is 2x. All right, then you divide all by the small change, which is the h. Then we have as the h approaches 0 here. We continue to evaluate. So now you can see that we have 2x here. So this 2x cancels this 2x. So we will be getting the limit of 2h divided by h as h approaches 0. All right. So at the end, we are going to get the limit of, so here 2h divides itself 1 and h divides this h. We have 1. So 2 times 1 will give us 2. All right. So we having h approaching 0, the limit of 2 as h approaches 0. So we have done this, we have learned a lot under limits of functions. We learned a lot under limit of constant function. So if you have a constant function, you have to take the limit of that constant function as the input approaches any value. The result is still the same as the constant function. So the limit of 2 as h approaches 0 is the same as 2. We conclude that our dy dx, which is the same as the gradient of the function, is equal to 2. Is equal to 2. All right. So this is the answer, which is the same as what we got when we use the comparison approach, where we compared the equation 1 to the equation 2. So the answer is the same as using the first principle approach. Thank you for watching. And do not forget to follow, share, and subscribe to my YouTube channel, which is Maths with Ebefa. Thank you so much.